Can you tell me a little bit about your background and how you got into the embedded systems industry?
Yeah, I actually, I wouldn't say I'm quite old, but I definitely grew with the whole tech industry. Started out when I was around 13. Bought my first home computer, which at that time was something called a VIC-20 with around 5 kilobytes of RAM. Started, yeah, bought my next computer, which was a Commodore 64, which probably is small, well-known, very small 8-bit computers. And I actually started to write small programs in first in BASIC and then in assembler language, actually. I then moved up to Amiga and PC and so on. And actually, when I finished high school, my idea was to be some kind of engineer, building engineer, mechanical engineer, something like that. I thought that say computers would just be something I did in my spare time, because we were talking middle of the 80s or something like that, 90s. So nobody knew yet. These computers, what's going to happen? How big is it going to be? And say basic engineering stuff, that's going to last. I wouldn't say forever, but at least the next 100 years or so. So I kind of became an engineer or expert on Unix-based system. I was running Linux. Before nearly everybody else. Some of the first versions downloaded via the internet. And so, yeah, that's kind of my way into the computer industry. I also, when I was finished, I actually worked in, you can say, the high-end internet industry for some years before I came up with this. Why not use Skype for IoT, which is basically what we do at the company. Remote access to small devices. So that kind of made my way back to microcontrollers, because I had a long period where it was more high-end server stuff.
So, kind of talking about embedded systems and everything, and you kind of alluded to the fact that you're running a company. Could you tell us a little bit about the name of the company, and a little bit about what you do there, and how long it's been around, and some of the stuff that you guys are doing there?
Basically, the vision is to use the same technology as that is beneath Skype. Probably also what we're using here for this recording, something called peer-to-peer technology, where you can traverse firewalls and get a direct connection from two peers on the internet. And the vision was basically, why not use this for IoT? If you have a client device, that could be a smartphone. So we started out before there was something called a smartphone. So when we started out, it was actually, how do you connect a PC to an embedded device? But today the use case is mostly, how do I connect my smartphone directly to my device? It could be a video surveillance camera, and be in real-time communication with this video surveillance camera. Or it could be an alarm system, and the benefit of this is, of course, very low latency.
Very excellent. Very cool. So now I know one of the things that we had talked about wanting to discuss here, and I think a lot of people will be interested in, is talking about real-time operating systems, and specifically starting to talk about the battle for open source real-time operating systems. So do you want to maybe explain what your idea of a real-time operating system is, and why it's important to people who are working on connected devices today?
Yeah, gladly. I will start saying what instead of you can say the direct definition, I would probably rather say do some examples, because I've been on all the levels, you can say, and a real-time operating system compared to, you can say, a high-end real operating system is a complete operating system. Is that a real operating system like Linux or Windows or Mac OS is something that totally abstract away the hardware. Programs cannot access the hardware directly, or at least not without getting admin root access or something like that. So the idea is to completely abstract the hardware away so that programs cannot interfere with other programs and so on and so forth. And then you of course have so that's that's a high end. And if you go all the way down, as I say, bare metal, which where I started, it's more like you do everything yourself. I see a lot of 10 years ago, a lot of devices would actually just run on bare metal without any real-time operating system, because I mean the type of application you would do at that point was normally very simple. I mean, a simple thermostat, I would say, would just wait until the temperature is at some level, and then it will start up or shut down the heating. You don't need much operating system for that, and that's what I have seen. If we look at it at a historic aspect, I mean, all this IoT actually has pushed the embedded industry from could run on a bare metal system if you didn't have any, I mean, real time. You of course have applications where real time, all this you have to stop and start and exact time slices and so on and so forth. Then you would have a real time operating system. But a lot of the devices out there, I mean, they didn't need a real time operating system. But with the introduction of internet into these devices, things have just gotten so complex that you had to move up. And that's what I've seen. I mean, the last 5, maybe 10 years, I mean, the industry has really, really matured up to at least real-time operating system level, and sometimes even all the way up to higher-end operating system. Normally, Linux, Microsoft tried with embedded Windows, and I don't think they do that much more. I think it's still out there, but I don't see much traction. So normally it would be Linux. But I also believe that the last step for this type of application, for embedded use cases, is normally too much, because you probably want to do something directly in hardware, but and also you don't have the need for multiple. I mean, the separation of multiple programs running on top of each other, because you have full control. You know exactly what is on the embedded device. So and that's not the case. I mean, with real operating system, you never know what the user is going to install. So there's a big need for this total separation of the hardware. But whereas in an embedded system, this extra complexity moving up to a real operating or high-end operating system is maybe just too much. And then of course you have a lot of hardware guys out there, and they are not that keen on being moved all the way up in user space and not being able to access the hardware directly. So I think this is what we're going to see. Embedded devices, at least for the next foreseeable future, will probably run. Most of them will run on a real-time operating system. The bare metal system will be cut off, and that's because of the internet. And again, because on the internet you get some communication from somewhere, and then an interrupt happens, and then this has to be handled, and you have an IP stack. So, and again, it's also nice to have memory allocation and being able to stop and start, and synchronize threads, and so on and so forth. So I think that's what is happening. What's going to happen is we're going to see much more traction on the real-time operating system, which is just validated by Microsoft buying ThreadX and Amazon RTOS. So I think it's even today it's old news, because it is already there.
Yep, most definitely. And like you mentioned, the purchasing of a lot of these real-time operating systems over the last couple of years has really been I guess staggering. To some degree, it's even affected how people are going to develop their systems. You mentioned ThreadX being purchased. You had free RTOS. You actually had Micro COS 2 and 3, which Silicon Labs bought. So it's a little bit different, where Microsoft and Amazon were big cloud players, in Silicon Labs is more a microcontroller vendor. But there's a consolidation that's kind of occurring in the industry. But
and it was a smart move. I mean, and I could say I saw it coming, but I cannot reference anything. But I mean, it was a smart move for them because again, a lot of the decisions out there. I mean, they're starting in. If you look at how do you develop product? Starts in product management. They find out a new idea. They write a lot of specification on what this product has to do, this and this and this. And at some point, they go to the engineers. They'll convert those, you can say, high-level requirements to something more specific and find out, okay, how many input outputs do we need? They're trying to estimate how much compute power do we need and so on and so forth, and what preferable interfaces do we need and so on and so forth. And then they're going to look into what kind of software is supporting this this device that they now found, or this microcontroller that they now found. And you better be there with something that can integrate to your cloud system. Otherwise, otherwise they're going to choose. I mean, they're going to choose whatever software they can get support from the microcontroller or in any other ways. And if it works, that's probably going to chip in onto which cloud to use. But that's also what I see right now. I see this siloification. So if your choice is free RTOS, probably you're gonna build your complete system up on top on Amazon services.
Yeah, and so I think that's interesting. So if you look at, kind of talking about Amazon and free RTOS, free RTOS, was an open source real-time operating system for years. Azure RTOS, which was, formerly known as ThreadX, was always a commercial one. As we start to look at this idea of, open source real-time operating systems, do you have a definition in your mind of what kind of a real open source real-time operating system is? And what that looks like today?
We should look at how is it controlled. I mean, who decides which features to put in there, and that kind of. I think I'm not sure I can do a definition. I mean, like in a math definition or something like that. But I do think there's some elements in there that has to be there for it to be real open source or true open source for me. And that is especially the decision process of their operating system. I mean, who decides what to put in and so on. And it's not so much how rigid it is, because if we go to Linux, there are some stories about some of the maintainers being very rigid on what can go in and what can not go in. But it's an open process. And people, they can say, I would like to do this instead, and we all vote about it, and so on and so forth. But as you say, free RTOS formerly was what I would say was a real true operating free RTOS real-time operating system. And I really like Richard Barry. He has actually been visiting my home, and me and my family had dinner with him and everything. And I really greatly admire his work. I mean, he has done so much. And I fully understand why when Amazon came to him, he did what he did. I mean, I would do the exact same thing. But to me today, I mean, it's not a true operating system anymore, because it's so much in the, even though you can say it's still Richard imagining, and it's handled by a very large that I mean, the whole purpose is making profits. And whereas the Linux Foundation is it's a non-profit organization and well known, and have established standards on how to do things. So I'm much more. I mean, Zephyr is open source. Free RTOS, not so much anymore.
I think you're absolutely right. The idea that open source, it's really the whole community is contributing to, the direction of it. There's like you mentioned, there's discussions and people, the community deciding what goes in and what goes out. Whereas now, when you look at some of the other ones that are being purchased by a large tech company, Not that necessarily they're going to do things that are, that would still help the community, but they are driven by a different beat of the drum, right? Shareholders and things like that. So, and maybe even the integration paths in the future for other products that they're developing. So.
And again, I mean, it's not that's how that's how the system works. I mean, that's how companies work. So it's not. I mean, I also run a company, and of course, if a company can kind of manufacture, you cannot do a monopoly IoT, but you can at least try to get people locked in, and then you can kind of have your own monopoly inside your own silo. And definitely that's what they're trying. They're trying to lock people inside their silo so they cannot get out. And then of course they earn money. I mean, that's I think that's a pattern that is all the way through all kind of tech companies out there, Microsoft, Apple, and so on, Google, and so on and so forth. It's all about making these silos.
Yeah, absolutely. And there's a lot of benefits to IoT developers and embedded developers to be able to leverage a silo like that, right? When you start to have all those integrated stacks, you can, instead of having to integrate all that yourself, the internet's just there. I can focus on my application code for my product, and that can, if you can live with the silo, then there's a lot of benefits that can come with that. But
I have read a lot of documentation in both silos, I would say, and both of them, as I say, I only see those two major silos right now, Microsoft and Amazon or AWS silo. And both of them, they state that, of course, you can move this application code that is on top of the real-time operating system to something else, in theory. Because as you say, the amount of work you have to put in to moving this and implementing it, not going to happen. If you are a developer out there and you're going to tell your boss, okay, I would actually like to use, let's say, Zephyr. I just have to move all this application code over to Zephyr, and it's only going to take me something like 100 hours. No way you're going to get that decision through the board. Or management.
Yeah. And so I think it's interesting because we have been talking about these, kind of the commercial solutions and the IoT stacks, that Amazon and Microsoft provide. There are developers out there. There's always been a very strong movement for using open source software within the software community. We love our open source tools. I mean, you look at GitHub and all the other different repositories out there that are open and have open source software. I mean, there's a lot of people contributing to the community, and so. Yeah. Why don't we talk a little bit about Zephyr and some of you defined it as kind of a true open source real-time operating system. Could you elaborate on that a little bit and let us know maybe where you see its place amongst these when you have these two big commercial providers, where does Zephyr kind of fit in there for people?
Right now, I definitely on you can say internet, non-IoT systems, because then the complete stack on top is not important. I do also see it from, I'm just guessing, but I do it seems like some of the microcontroller vendors, they're like, okay, we have to support both Azure RTOS and free RTOS, Amazon's RTOS. Let's just go with Zephyr, and then we're on the sideline. And then if people want the other two, they can just support it themselves. I've seen some of that, especially in some of this new low power thread. If you have worked with Thread Matter, some of these radio modules and stuff. It looks like it actually has traction on Zephyr. Don't know why. It could also just be historic reasons for some of these microcontroller vendors. But it could be, you could say that some of the microcontroller vendors doesn't want to choose, and they definitely do not want to support both silos. So they just go on the sideline and say, well, let's just do Zephyr, and then we haven't chosen anything yet. That could be, but otherwise I actually see Zephyr it's going to be a hard time moving forward for open source, because I mean these two, I mean Microsoft and AWS, I mean they are big players. I mean, they have a lot of resources, so they can make a lot of things easy for you if you choose their environment or their platform or silo, you can say. It's going to require a lot of open source developers out there to be able to match that.
Okay, gotcha. And I have seen, so I don't know if you've seen this as well, so I'm be kind of curious to hear what you've been seeing. So with Zephyr, I have started to hear or see a lot of traction. Like they have, for example, I think it's in Prague coming up in June. They have like a developers conference. I've started to see some of the silicon vendors, pushing Zephyr a little bit more, like you kind of alluded to.
Yep.
So do you're really seeing this as more of kind of a disconnected solution, or are you starting to see traction with Zephyr in such a way that we may see, I don't know, third-party stacks or things that help you connect to, AWS or Microsoft?
I can tell you what we do. We want to support all of it, but we also have a very agnostic mindset, you can say. So, but again, we also have to choose some platforms and again say some platforms will help you or will do it together. I mean, for our customers, but also so today we do our software is agnostic. So we have an abstraction layer, and then if you implement that, you can run on the one or the other. And Zephyr is one of the operating systems we say we have to support that because we do see traction. But also to tell people, well, we have of course FredX and FreeRTOS, but we also have you can say open source alternative if that's what we want. But I do also see, I wouldn't say the market is mature, but maybe it's not that mature yet because my guess is, or my experience is that some of the projects out there, or some of the companies out there, it's maybe only the first evolution of their real-time operating system product. So I mean, it's also about them getting up to speed. And I mean, if it's the first project you do, or maybe the second, you probably not want to take too much risk. So you're gonna go with FreeRTOS or FredX or something that is fairly well known and have everything implemented for you, or at least a lot of it. And then I think when you start playing around with when you start playing around it or the real-time operating system, you maybe go and say, okay, maybe you should not get too much locked into one platform. And then so it's maybe also just a question of time. Again, I don't know, but right now, the exact moment here, I see Zephyr having a hard time, but I also think it's maybe just we should wait and see what's happening.
Yeah, I think I find it interesting because when I originally heard that the Linux Foundation was going to create the real-time operating system Zephyr, being a microcontroller person, my response to that wasn't, woohoo, cool, there's going to be this open source RTOS. It was, oh dear God, here we go, another RTOS, right?
Another standard.
another one, right? But since then, I've kind of seen, like you've been talking about, FreeRTOS is kind of these, a standard open source one. We had ThreadX, Azure RTOS, but Zephyr really has, in those years kind of shown to be, at least within the last couple of years, kind of a third major popular one that, like you said, I think has some issues or some struggles going forward, but is also maybe starting to gain traction enough to maybe be able to overcome some of those. I'm not 100% sure yet. I guess time will tell, but.
I could try to pitch another crazy idea. It could be actually that FreeRTOS and the Amazon silo could be in trouble. If you follow my argument now, I'm not saying it's going to happen, but this could also be what's happening in the future. I mean, so you have Microsoft, because what I see right now is a lot of companies, IoT is moving from something that they just want to show on a trade show, something where it was not real product. I mean, we have customers where the only reason we had a project from them was that okay, they had to show something on a trade show relating to IoT. And then we were there and we implemented the project. And suddenly some time went on, and suddenly they were like, okay, all our products are now nearly, customers are actually asking for IoT. So now we go from some marketing gimmick to real production. When you get to real production, suddenly the IT department is involved. I mean, the ones running servers, running your mic, your laptops, your PC stations, and all that, and probably also your ERP systems and your website and everything. And these guys, I wouldn't say are Microsoft, but I would say mostly Microsoft minded. I mean, because if you go to the industry, I mean, most, of course, you would still have Apple, but I see that mostly by developers. If we go out in the industry and you see a person from sales or so on, it's a lot of time it's a PC Windows based. So what I see right now is this movement from, yeah, you can say marketing gimmick to production actually involves getting the IT department more and more involved in the process of the product. And these guys, if without any specification or anything else documented, what they will say is we have to choose Microsoft because that's what they know. They already run probably Office 365 and so on and so forth. So right now I see, even though Microsoft was a little late or later than AWS, it definitely to me looks like they're getting more and more traction in the IoT industry, and they want to be in there getting people to decide that they have to go to Microsoft. So it could be that in the future you have Microsoft being the winner of the embedded and IoT development, and then you have an open source operating system, and then you have a minor player being Amazon. I know it's a crazy idea because right now they have lots of traction too, but
yeah.
So it's just a crazy idea. But it could be in the future. Actually, Zephyr is the open source initiative, and then you have the good old Microsoft being closed source and all the good and bad things about that. And then you have something where Amazon kind of falls to the second place, or it would never. I don't think it will ever be completely out of the market, but maybe not as dominant as they are today. I know, crazy idea, but
you know what though? That's what that's what business leaders and stuff like that in the industry do, right? We look at the landscape and we have a crazy thought or idea, but it's a prediction for what the future might bring, right? And so I think it's it's a valid prediction. So so for sure. So I find that to be very interesting. And I think that there's a Zephyr, you mentioned some challenges with connectivity stacks. I've kind of seen Zephyr maybe as having I'll say training type of issue, because Zephyr borrows a lot from like the Linux style of doing things, right? It has a device tree. It uses tools that are very similar to Linux based development. What kind of challenges do you see between like a someone who traditionally works in embedded microcontrollers adopting Zephyr versus maybe someone who is using Linux already and looking maybe to do some embedded work or some IoT work? Could you maybe talk a little bit about that?
I actually want to maybe change the direction a little, because what I actually have seen a lot of discussion about is actually we need more embedded developers, basically, because right now everything is moving onto internet, and I see a lot of discussion where are these people going to come from. Of course, there's the education system is pushing out a lot of people, but are we going to catch some of the Linux guys and get them, I mean, down to doing embedded stuff? And one of the things, if we have talked a lot about the future, because one of the things I see is some kind of combination of real-time operating system and interpreters. So maybe not the usual suspects like Java or other type of, but more specific languages that are made for embedded programming, and then you could maybe get some of the more high-end programmers to actually develop on the embedded stuff, and you can reuse those guys. The competencies that you already have in-house could actually be used on that. That could also be kind of one of the rescues for Zephyr, because then suddenly it doesn't matter that much which real-time operating system or microcontroller for that matter you want. If you can just implement the interpreter, you're up and running, and then you can choose from any silo or any environment. So that could be that could be a way that Zephyr could actually win the complete market. Well, not the complete, but not be left out. I would rather say. But again, I think I also talked about in the start. I do see some pushback on this, because especially from the old embedded engineers who are used to compiling their own C code and moving bits around and talking directly to hardware, they are not that keen on using these high-end languages. To them, it's they're getting way too far away from it, so they don't like it. But it's who knows? Because right now we have had this push from, you can say, bare metal up to real-time operating system. Next step could be up to some higher type of abstraction, and I don't think it's. Many people say, well, it's going to be Linux or some other kind of high-end operating system, but I think that's too much complexity. There has to be something else in between, or at least because running Linux on a small device, I mean, too much complexity for what you're actually trying to solve. So it could be these other environments, interpreted environments, where it's much more easier to reuse code and much more easier to push out new code, and so on and so forth. Probably went too far away from the path you set out, but it was just an idea that I can remember I thought about here the last few days.
Yeah, no, I think that's great. I think that's a real important point, actually, to to keep in mind for people. So I know several years ago I wrote an article about the soon-to-be extinct embedded software developer. And the reason I wrote that was because I saw this trend of, we need so many embedded developers, but we can't produce enough. And there's so many high-level app developers that at some point you just, and the computing technology for microcontrollers has evolved so much from, the basic 8-bit microcontrollers we use, even though they're very popular, surprisingly, in the market. But, there's this elevation that's essentially required away from the low level stuff. Just like we saw, originally in the computer industry, so many decades ago, where it started low level and then it moved to, Windows and Linux and high level operating systems. So,
the big question is probably, did you write that article a little too early? I don't know.
Probably, I wrote this probably like 5 years ago or something like that. Every now and then I get, maybe it was pre-COVID for sure. And every now and then I will get a person emailing me saying, I read your article, and should I go into embedded systems? And they're all worried because they're, a third-year college student and they've already started down the path. And it's, no. There's high demand for embedded developers, but if you can, do a little bit of both, I guess you could say, or, just be aware that, the industry evolves quite rapidly. So, but
we are all going to be replaced by AI anyway.
Yeah, exactly.
not to start a totally new thread here.
Yeah. Just, you mentioned that literally right before this call, before our call here for our discussion, I had another call with a company that's doing, essentially using machine learning to read data sheets and allow a developer to create a model of the chip or the part, and then allows them to very quickly develop hardware abstraction layers and the code for those chips. And so, again, kind of saying
with it, and we are impressed too here on how much it can actually help you. I would never, I mean, let it unguided or what's it called, unmanaged, but actually to help people with. So we have this abstraction layer on operating system, say how to actually. And our customers, or if they choose, I mean, if they come with a complete new type of system, some kind of, let's say, internal real-time operating system, that they have to implement this layer themselves. We are actually experimenting with the AI, if it could actually supply us with the, and it was quite good. I mean, it could read our documentation and it would actually tell, and the real-time operating system documentation, and then it could get quite far at trying to make these adapters. We were very impressed, I would say.
Yeah, it's really amazing, and just the fact that it's in my mind still quite early, right? I mean, it's
yeah.
You look at where the industry's gone, and just or where it seems what's evolving over the last 6 months, and just the exponential curve and capabilities that are coming out. It's quite amazing. So.
Yeah, and going back to where you said, well, you have people asking you if they have the right path doing embedded stuff. I do think that my advice for people when they ask these kind of questions is that you shouldn't be too much focused on just one part of the industry, because I mean, it's not, servers are not that much different from microcontrollers. It's just, I mean, they're just bigger, run faster, and of course they have an MMU and stuff like what you don't see on the small. But again, I mean, today I think it's hard for people to stay focused and just do one part, a little corner of the industry. I mean, because today it's getting, I mean, if you go 10 years back, you could have your small device and you can just stay in there and you can, but today it's internet connected. It has to be connected to apps. It has to connect to servers. Probably installers have a PC program they have to connect. So you have to be, at least you have to have some knowledge of the different systems, and it's just so much easier if you do, and also your choices are so much bigger. So normally when people say I want to be an embedded developer, I'll tell them, well, maybe you should just try to be a developer, and then with that focus on embedded, that I think is actually the best advice I can give people like that, because yeah, you never know, and to get back to the other point, we're going to be replaced by AI anyway.
Yeah.
Well, of course not, but
Yeah.
It's
but I think we will. I don't think like you're saying. I don't think we will be replaced, but I think we will be very much augmented in the development cycle by AI.
Yeah.
All right. So once again, I want to thank you for your time and sharing your thoughts today. Where could listeners potentially go to learn a little bit more about you and the type of work that you're doing?
Well, they can go on our website. That is nabto.com, nabto.com. They can actually, you can test out our products for free. You could, once you sign up on our console, you can actually create up to three devices for free. So it's, and again, we try to support all kind of operating system, even down that. So it's we are trying to support it all. So it's of course, you can also go on Twitter. We have a Twitter feed and also a Facebook feed. So feel free to contact us in our chat, because we always have embedded engineers there to help you.
All right, perfect. Thank you.